Hey there, this is a screencast where I'm going to work some indeterminate form examples for you. Actually, I'll just work one. I'm going to work an example we did in class because it was kind of complicated, and maybe you'd have appreciate having a copy of this going forward. Let's take the limit as x goes to 0 from above of 1 plus sine of 4x to the cotangent of x. The denominator here, it's going to 1 plus 0 because sine of 4x is going to 0 as x goes to 0. And so 1 plus sine 4x is going to 1 plus 0 is 1. In the numerator, cotangent is cosine over sine. So as x goes to 0 from above, and this is where it's important, the sine is going to 0. And as x goes down to 0, the sine is going to down to 0 as well. So it means it's positive, getting smaller and smaller. The cosine is also positive near x equals 0. So this whole thing is going to be positive, and it's getting bigger and bigger. So this is going to infinity. So this indeterminate form is of type 1 to the infinity. Okay? Definitely an indeterminate form, one of those that I mentioned. So we have to take care and use L'Hopital's rule to do this one. There's no obvious way to simplify this expression that we're taking a limit of. So we just have to use the techniques of L'Hopital's rule. And this is the standard way of doing it when you have something happening in an exponent. Okay, we want to get it out. So let's write the expression in our limit as y. And then let's take the logarithm of both sides. And the logarithm is a standard tool for getting something out of an exponent and down into the base where you can work with it. So actually, if I do this right, should be like that. So by the property of logarithms, that cotangent up there can come down as a multiplier, and we get this. So what's happening here? This is going to 1. Therefore, this whole thing is going to 0. And this is going to infinity. So infinity times 0 is another indeterminate form. I'll write that over here. Infinity times 0. To use L'Hopital's rule, we need to have an indeterminate form of a type 0 over 0 or of type infinity over infinity. So what I'm going to do is I'm going to take this cotangent and I'm going to put it in the denominator. So I'm just using algebra to rewrite. So I'm going to do natural logarithm 1 plus sine 4x over 1 over cotangent x. Now I'm running out of vertical room, so let me just move over to the right one so I can write this. This is the same. 1 over cotangent is the same thing as tangent. So let's double check this. So we have this, and we're taking the limit of it as x goes to 0. So we know the numerator, that's going to 0, and the denominator, that's also going to 0, because tangent is sine over cosine. Sine is going to 0, cosine is going to 1, so all of tangent's going to 0. So there we go. That's the kind of indeterminate form we want to have. Let's apply L'Hopital's rule. So the limit as x goes to 0 from above with the natural log is the same as the limit as x goes to 0 from above of this expression. And you may be a little annoyed that I'm recopying all this, but it's good to know exactly where you are. Here I'm going to apply L'Hopital's rule. So differentiating the numerator, the derivative of the log of something is 1 over that something. And then you multiply by the derivative of that something, so we get 0 plus cosine 4x times 4 by the chain rule. And the derivative of tangent is secant squared. So let's clean this up a little bit. The limit as x goes to 0 from above of 4 cosine 4x over 1 plus sine 4x times 1 over secant squared x. So where are these things going? The secant squared here is x goes to 0 from above. Secant is 1 over cosine. As x goes to 0 from above, cosine goes to 1. So secant is going to 1. So secant squared is going to 1. Cosine 4x, as x goes to 0, cosine 4x is going to 1. So this numerator here is going to 4. And sine 4x, as x goes to 0 from above, that's going to 0. So our limit here equals 4 over 1 times 1 over 1, which is 4. Okay, great. L'Hopital's rule really helped us. We're not done though, because we've just computed the limit of the log of y. Now we need to go compute the limit of y. So the limit as x goes to 0 from above of y is the limit as x goes to 0 from above of e to the log y. Okay, again, just using an identity we have for the natural exponential and the natural logarithm. And then we use the continuity of the exponential to move this logarithm inside. And this is the limit we just calculated. We calculated that to be 4. And there we go. So this just shows that the limit as x goes to 0 from above of 1 plus sine 4x to the cotangent of x is e to the 4. There we have it. Okay, see you in class.